Hello! Currently I'm participating in a music project that involves on-stage performance with the Akai Electronic Wind Instrument and running the audio Modeling Camelot software on the MacBook Pro. This video shows the hardware and software setup for live playing a full multipart horn section with the EWI as MIDI input controller. At this moment we are rehearsing for a music project with local musicians performing at the village summer festival. Being the only horn player, I've been thinking about how to create a setup for playing a full multipart horn section using my Akai Electronic Wind Instrument and the audio Modeling Camelot software on the MacBook Pro. I came up with a quite intricate instrument and software setup and will discuss the necessary setup steps in this video tutorial. I recently did a similar tutorial about how to implement a sidechain audio channel in the Camelot software. Here's the hardware setup for this project. It involves 4 essential devices. The Akai Electronic Wind Instrument is the real-time MIDI input controller. Pitch is determined by keys and octave rollers. Mouthpiece blowing controls the expression, the dynamics. Biting affects the growl intensity. The glide plate is used for vibrato control, and the EWI also has pitch bend plates. On the iPad I developed a TouchOSC model to control project navigation, selecting setlist songs and scenes. Pressing the panic button at the top stops hanging notes. The faders are not used when there is EWI input. At the core of the system is a MacBook Pro with the audio Modeling Camelot software. This song scene shows a set of layers with virtual instruments loaded. The main plugins are the EWI acoustic samples V-horns and a set of swarm instruments. The typical horn section is a 5-piece group with trumpet, alto and tenor saxophone, trombone and baritone sax. The Arrow audio interface has 2-channel stereo output going to the front of house mixer. The setup process for the horn section playing involves 4 steps, shown in diagram and discussed next. My setlist contains a dozen songs with various size horn sections, between 4 and 7 pieces. Also some winds, strings and percussion, for which I use a MIDI keyboard with sustain pedal. While listening to the original song audio, I prepare a Dorico reduced score with bass and horn parts, plus the harmony chord labels. There are 3 typical horn section musical elements. First, all horns playing melody in unisono octave doubling, with at the top trumpet and alto sax, in the bottom octave tenor sax and trombone, or in 2-part parallel intervals. Then there is the baritone sax as bass part doubling, and the third element is multipart harmony, in 3 or 4 voices, with aspects such as voicing and part distribution. Polyphony is impossible with the EWI, but these songs typically use stab or sustain chords. When playing the EWI, I take into account a number of aspects. I find 3 to 4 octaves a practical playing range, so I have about 45 MIDI notes available, a number that becomes relevant later in the process. I divide that compass into sub-ranges for the various musical elements. The lower range is reserved for the baritone sax solo bass parts. The intervals given are indicative and may vary for each song. MIDI notes in the mid-high range are used for unisono and octave doubling horns phrases, usually with melodic character, which leaves the free notes in the lower mid and in the upper range for chord playing, discussed in detail in the next step. Note that the EWI part contains quite a few multi-octave leaps. These are tricky to perform reliably with the octave rollers on the back of the instrument. At the end of this step, I will have compiled a spreadsheet with the mapping for the EWI. This is a table with typically 35 entries. Given the spreadsheet for the song, I add a grand stave to the Dorico score, which will become the EWI part. This will reveal the wide leaps, and there may be musical phrases that make no sense musically, since EWI notes will not correspond to the sounding pitches. There's no room for improvisation, Sometimes I have to adapt the mapping table in an iterative process. The end product is the EWI part, ready for rehearsal. In the final step, the song setup is implemented in the Audio Modeling Camelot software. I create a scene for the song and load the instrument plugins in parallel layers, here the typical 5-piece horn section. I set the key range for each instrument, which may be adjacent or overlapping. And now comes the nifty bit, where I go into the MIDI settings for each instrument. In order to implement the note-to-chord mapping for each instrument, I activate the note-to-chord option. I also will need the humanizer activation and optionally may adapt MIDI CC response curves or remap and filter these. Let's look at the note-to-chord feature, which originally is meant for one-finger chord playing, which corresponds to a one-to-many mapping. I cleverly used this option for a set of parallel one-to-one note mappings, different for each instrument. Here you see an example where the EWI input note C3 is mapped differently for the 5 horns in order to obtain a C major triad voicing. The result for the alto saxophone for this song is a set of about 20 entries, 20 one-to-one note mappings as specified in the spreadsheet. The next aspect is to humanize the performance, editing the randomness values of the humanization parameters. This prevents a perfectly simultaneous timing and articulation, which would give the horn section a robot-like character. Instead, there is a more human-like group performance. We proceed with the Camelot mixing. Add audio effects at the layer, song or setlist level. Here, this mainly involves a bit of reverb, for which I use the FabFilter Pro R plugin, which does not yield significant latency. Real-time response, after all, is very important. I may have adapted the EQ settings in the instrument plugins or at the layer level. In the Camelot mixer panel, I set instrument panning, the volume for each instrument in order to achieve section balance, and the song and scene audio gain. This means I can leave the audio interface monitor output level fixed, and the front of house engineer will have an easy job mixing in the horns. After all this talking, I would like to demonstrate the setup with a couple of audio examples. To that end, I created a simple Cubase project. This has a rhythm section background with ample sound acoustic bass and a tune track Superior Drummer Jazz Brush Kit. I took the Camelot software audio output and routed that to a Cubase stereo input channel. I will now play a number of phrases and fragments that include the different musical elements. Here's a phrase from the beginning of the song. The 2 grand staves show the sounding horns and bass part at the top, while the bottom staff is the part I'm playing on the EWI. This phrase has 2 horn section chords that involve note-to-chord mapping for all 5 instruments. Here's the phrase that has unisono octave arpeggio patterns at the start, the characteristic low baritone saxophone in the middle, and the chord stabs at the end. Note the wide leaps in the EWI part. The next phrase has frequent juxtaposition of baritone saxophone and middle register horn section chord patterns. Listen to the 5 chords involved and note the mapping that still makes sense here. And here's the EWI performance of this horn section phrase. The next phrase has a similar rhythm, but the horn harmonies are now in a different key. Note the first case of a peculiar mapping of the EWI G3 pitch to the F-sharp minor triad. Also notice the effect of the humanization settings. For the second audio demonstration, we move further into the song. The bridge section has a nice case of horn section unisono playing with octave doubling. Here you clearly hear the effects of the humanization settings. The phrase closes with a chord. This is followed by a repeat of the phrase we heard earlier, and where we have the peculiar note-to-chord mapping. Listen to the 4 triad voicings in isolation. The EWI performance has the frequent juxtaposition of baritone sax and horn section harmony patterns. There's a wide but doable leap for EWI at the end. Let's proceed with the final example. I wanted to demonstrate these 4 note-to-chord mappings since they show how, near the end of the song, I'm running out of available free pitches in the low-mid EWI playing range. In my effort to avoid very wide leaps, I decided on these illogical MIDI notes, and also there's a nice example of how the humanization settings affect the section balance in the opening D minor triad. Playing this juxtaposition of bass part and horn triad patterns is easy. This video tutorial is about live performing a horn section with the Akai EWI and the Camelot software. This proved a successful combination of hardware and software, and the goal was achieved. Clever use of the note-to-chord mapping in Camelot is required to enable EWI playing of multipart harmonies. There's a limitation though. Stab and sustained homophonic chords only, since polyphony is impossible on the EWI. There are occasional hanging notes. Is it Camelot or the virtual instrument plugins? I don't know, probably the latter. There's a lot of practicing required. There's no flexibility, no room for improvisation. I trained accurate playing and did special 2-octave leap exercises. It is stressful going on stage since there are so many possible system failure options, although the system proved stable and reliable during group rehearsals. When all goes well, it is great fun and never fails to impress other musicians and, most importantly, to please the audience. You may want to experiment with this setup yourself. There's many more video tutorials on this channel, and visit my website for documents and ebooks. For now, thanks for watching.